Okay. So let's continue. Probability and the additional rule and conditional probability. Like I said, reading is important. Kanun is important. These two things go together. You read wrongly, you write the wrong things. You don't remember Kanun, I don't know how we are going to solve. Lazim, we remember. Lazim. Okay? So, a review committee read 3,000 application essays for one 5,000 college scholarship. $5,000 college scholarship. If of the applications reviewed, 2,865 essays were the required length. Required length to see, as I'm reading, I'm writing what is important. So to me, 2865 is important before I look at these two values. Okay? 2,577 of the applicants had a minimum required grade point average. Minimum required grade point average. Okay. How many of them had this? 2,577. Okay. 2,486 had the required length and minimum grade point. How many? 2,486. Okay. So I'm thinking of my Venn diagram. Even before I read the question, I'm thinking of my Venn diagram. So here you had the length. Here you had the grade point average. Here is both. So both is 2,486. Now, required length is 2,865. So I will minus these two numbers to know who only had required length only. So 2,865 minus 2,486. 2,865 minus 2,486. That gives me 379. That goes here. Because this is length only. This number is for length only. Now, grade point only will be 2,577 minus 2,486. So grade point only, 91. And now, how do I know I'm correct? If I add these three numbers, I should get 3,000. If I don't get 3,000, I am wrong. 379 plus 2,486 plus 91. I did not get that. So how many people did not? Okay, then there are people who did not do. So then minus 3,000. So 44 people were here. Okay. All right. So 44 people did not have the required length and did not have the grade point. So these 44 people. Now, if I add all this, I should get 3,000. Okay, now let me continue. What is the probability that an application essay selected at random will have the required length or the required grade point? So, probability of length or grade point equals to probability of length, okay, plus probability of grade plus probability of length and grade. So probability of length will be, how many people have length? So this, add these two numbers, which is the same as this one. So 2865 out of the total, and the total is 3000. Probability of grade, add these two numbers, which should be the same as that. That should give you 2577 divide 3000. And then this should not be plus, this should be minus, minus the intersection, which is this one here. 2486 over 3000. Okay, so just put 3000 at the bottom and put these three numbers, these three values in the calculator. So 2865 plus 2577 minus 2486. And that should give you 2956. And then you simplify. That should give you 739 out of 750. Okay. I always try to use my Venn diagram so I can understand my question. You could have just come from here to here, or you could have done what I did. Okay. All right. Ruby's cat had 8 kittens. Ruby, 8. The litter included 2 orange females, 2 orange. This is Ruby. Okay. 2 orange, 3 mixed, 3 mixed. Oh, orange females, 3 mixed color females, 1 orange male, 1 orange male, and 2 mixed colors male. Okay. So this is me writing what I've understood. Ruby wants to keep 1 kitten, 1. What is the probability that she randomly chooses a kitten that is a female or orange here? So probability of female or orange, you can do this 2 ways. This should just be 2 out of 8, which is 1/4. So that's one way of you doing that. Or you can do probability how many? 2 orange females. Yes. Probability of female orange. Okay, let's do canon probability of female or orange equals probability of female plus probability of orange minus probability of female and orange. Okay, probability of female is how many females? 5 out of 8. Is this 8? 5, 6, 7. Where's the 8th? Ruby has 8 kittens. 2 orange, 3 mixed color. Those are 5. 6 plus 2 is 8. Okay. So those are 8. 5, 6, 8. So this is a total of 8. Okay. All right. Probability of orange. How many people are orange? 3 people are orange. How do I know? I have 1 orange here and 2 orange here. So that's 3 orange. And probability of both female and orange will be 2 out of 8. Okay. This is not correct because it says or here, so you cannot do this. This is probability of female and orange. Or you cannot do this method. Yes, I agree. Okay. So here will be 5 plus 3, which is 8. 8 minus 2 is 6. So you should get 6 out of 8. And you simplify by finding the greatest common factor, which should be 2, not 3. And your answer is 3 out of 4. Okay? There you go. Okay? So we move on. So when you do or, lazim you do this kanun. The kanun is probability of A or B means probability of A plus probability of B minus probability of A intersection B. Okay? All right, we move on. The table shows the age and number of participants in each sport at a sporting complex. What is the probability that a player is 14 or plays basketball? Okay, so a player is 14 or plays basketball. So this will be probability of being 14, probability of basketball, minus probability of 14 and basketball. Okay? Now, how many players are there? You have to add them. Okay? And the total players you should get is 300. Okay? Total players you should get is 300. So this plus this is 13, carry 1. 6 plus 2 is 8, 93. 12, 13, carry 1. 5 plus 4 is 9, 103. 5 plus this is 14, carry 1. 7, 9, 104. Okay, 93 plus 103, 93 plus 103 plus 104. You should get 300 players. So that's your total. Okay, so add this. They should all come to 300. So 300 is your denominator. Okay, me, I just like simplifying my work. How many players are 14? 42 are 14. Here. No. You're going to add all this, not 42. Add all these people. 28 plus 36 plus 42. So 28 plus 36 plus 42 gives you 106 players are 14. Plus, how many people are basketball? You're only going to add this one, which should give you 104. Now, how many people are both basketball and 14? 42. You do that, okay? Now, what should you get? Just do your numerator, 106 minus 104. Sorry, plus, not minus. Plus 104 minus 42. That gives you 168. And 168 divide 300. You simplify. You should get 14 out of 25. Remember, your answer must always be in the simplest form, always. Okay? All right. We're going to use a model. Vincenti and Kelly are designing a board game. They decided that the game will use a pair of dice and the players will have to find the sum. That means you're adding of the numbers rolled. Vincenti and Kelly created a table shown to help determine the probabilities. Each player will roll the pair of dice twice during the player's turn. What is the probability of rolling a pair or two numbers that have a sum of 7? Okay? What's the probability of rolling a pair or two? So a pair or two numbers that have a sum of 7. So probability of pair or sum of 7. Okay? So what does that mean? Probability of pair plus probability of 7 minus probability of pair and 7. Okay, let's see if this is going to work. Pair should be 1. Pair. What does pair mean? 2. Okay. So why is it not 1? Let me read again. Vincenti and Kelly are designing a board game. They decide that the game will use a pair of die and the players will have to find the sum of 7. Vincenti created a table shown to help determine probabilities. Each player will roll a pair of dice twice. Okay. What's the probability of rolling a pair or two numbers that have the sum of 7? All these are pairs. Okay. So that will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So out of 36. That's me just thinking. So 36 out of 36 plus getting a 7, we need a sum of 7. Sum of 7 will be here. 6, 5, 4, 3, 2, and 1, 6. That's the only time I can get a 7. How many are they? 1, 2, 3, 4, 5, 6. 6 out of 36. And probability of getting a pair and 7. So does this part make sense? Because this is the part. So why am I adding and subtracting? So I don't think this part makes sense. So this part we have to remove. Okay. So, but now my answer will be more than 1. So maybe when they meant pair, they meant the same rakam. If they meant the same rakam, then, but that doesn't make sense. This question is not worded correctly. They should have said the same number in the pair. Then yes. Then I will say here, I have 6 for the pair because it doesn't even say double. It only says here a pair or two numbers that have a sum of 7. So that's why I wrote 36. If you're a pair, all these are pairs. Pairs means two, groups of 2. It did not say anywhere here, each player will roll a pair of dice twice during the player's turn. Vincenti and Kelly are designing a board game. They decide that the game will use a pair of dice, and the pairs will have to find the sum of the numbers rolled. Vincenti and Kelly created a table shown to help determine probabilities. Each player will roll the pair of dice twice during the turn. What's the probability of rolling a pair or two numbers that have a sum of 7? Okay, your book says this is what we should do. So we simplify. I will come back to this. I have to understand why here this is 6. Okay, so then you simplify by using 6, which gives you 2 out of 6. Then use 2, divide by 2. So we should just have used 12. That's all right. 1 out of 3. Okay. All right. Vincenti and Kelly, okay, what's the probability of rolling two numbers whose sum is an even number? Even number, odd, even, odd, even, odd, even, odd, even, odd, even, 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 odd, even, 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 even. Okay? What's the probability of rolling two numbers whose sum is even? Probability sum is even, or not rolling a 2. Not rolling a 2 equals to probability of sum that is even, which will be something over 36. And that something over 36 is counting all my circles. 3, 3, 3, 3, 3, 3. 1, 2, 3, 4, 5, 6. So that would be 18 out of 36. 18 numbers. Okay. And then after I find that, I need to find the probability of not rolling a 2. So plus probability of not rolling a 2. So I need to take another color. I did not roll a 2 here. I rolled a 2 here. Here, 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 here. This whole column will go away because it has 2's. And this row will go away because it has 2's. So how many numbers have I removed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what is 36 minus 11? 36 minus 11 is 25. Okay? So 25 numbers do not have, or 25 spaces don't have the number 2. Then I need to subtract probability of sum is even, and not rolling a 2. Okay, so I am going to minus. Who is that? Let's choose a different color. So sum is even and not rolling at 2. So you're both. Sum is even here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? So 13 out of 6. Then I should just do 18 taksim 36. No. 18 plus 25 minus 13. That gives us 30 over 36. I will simplify by 6. I will get 10. No, I will not get 10. I'll get 5 out of 6. And that's my answer. Okay? All right, we move on. The table shows Parks and Recreation Department classes and the number of participants ages 7 to 9. What is the probability that a participant chosen at random is in drama or is an 8-year-old? Probability that you're in drama or 8 years equals to probability that you're in drama plus probability that you're 8 years minus probability that you're both drama and 8 years. Probability that you're in drama, first of all, let's count how many are you. 40 plus 20, 30 plus 20, 70, that's 90. So this here is 90. This is the 6, 10, carry 1, 3, 4, 6, 10. That's 100. 25 plus 9, 10, carry 1, 3, 4, 5, 50. So altogether, you are 90 plus 100 plus 50. That gives us 240. So altogether, we have 240 participants. Okay? So drama is 100 out of 240. How do I know? Look at my column for drama. It's 100 people. Okay? Now, how many people are 8 years old? 8 years, I will add these 3 rakams here. 30 plus 21, that's 51. 51 plus 14, that is 65. So 65 people are 8 years old. And then both drama and 8 is 21. Drama and 8 is 21. So 21 out of 240. So 100 minus 65, 100 plus 65 minus 21, that gives us 144 over 240. I can use 12. 144 divide 12 is 12. 240 divide 12 is 20. Then I can use 4. That should give me 3 out of 5. Okay? And that's our answer. Okay? Erin is planning her summer garden. The table shows the number of bulbs she has according to type and color of flower. If Erin randomly selects one of the bulbs, what's the probability that she selects a bulb for a yellow flower or a dahlia? Okay, so probability of yellow or a dahlia equals probability of yellow plus probability of dahlia minus probability of both. Okay? Probability, first of all, let's count how many there are. 8, 10. Here is 10 orange, 5, 10, 11 yellow, 5 plus 10, 15 white. Altogether, 10 plus 11 is 21. 21, that will give us 36. So 36, 36, 36. Okay. Probability of yellow, 11. Probability of dahlia, 5 plus 4 plus 3 is 7 plus 5, which is 12. And probability of both yellow and dahlia is 4. Okay. So then here, this will be 11 plus 12 minus 4. That gives us 19 out of 36. 19 is a prime number, so you cannot simplify this fraction. So this is the simplest form. Okay? The Spanish club is having a potluck where each student brings a cultural dish. The 10 students randomly draw cards numbered with consecutive integers 1 to 10. What does that mean? Consecutive integers, they cannot be decimal. And from 1 to 10, so you write them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Students who draw odd numbers will bring main dishes. Odd numbers, you bring a main dish. Students who draw even numbers will bring desserts. Even, you will bring dessert. If Cynthia is bringing a dessert, what is the probability that she drew the number 10? Okay, so there's only one 10. Out of how many numbers are this? So this is the conditional probability. Okay, the question says probability that Cynthia drew what? Cynthia is bringing a dessert and she drew a 10. So she must have drawn a 10 first. So 10 here and then dessert here. Okay. So dessert was the last thing, because how did she know she needed to bring a dessert? She must have gotten a 10. Now, because this is conditional probability, Kanun says probability of A intersection B taksim probability of A. Now, who is our A? Our A is 10. Who is our B? Our B is dessert. What's the probability of getting a 10 and a dessert? That should be, okay, first of all, I like writing this. This becomes probability of A intersection B divide probability of A. Okay, now there's only one 10 out of 10 numbers. Our total is 10 numbers. Total is 10 numbers. And how many of them are 10? Only one. So that's why I wrote here 1 out of 10. And then I am dividing with the probability of getting a dessert. To get a dessert, you must have even numbers. 1, 2, 3, 4, 5. So 5 out of 10. Okay? Now, so this will be keep, change, flip. 1 out of 10 times 10 out of 5. This and this goes away, and your answer should be 1 out of 5, and you box your answer. The question did not ask me to write it in decimal. You can write it in decimal, you can write it in percent. This is 0.2, and this is 20%. All these are your answers. Okay? All right. A card is randomly drawn from a standard deck of cards. What is the probability that the card is a king of diamonds given? The minute I see this, I know it's conditional probability. Given that the card drawn is a king. Okay? So this is the probability that you have. Who was drawn first? What is the probability that the card is a king of diamonds given that the card drawn is a king? Okay, so first you drew a king. That is event A. No, first you drew a king of diamonds. Or you drew a king, okay? First you draw a king, and then you drew, and you want to see if it is a king of diamonds. Okay, so probability that you are a king and diamond over a card is drawn randomly from a standard deck of cards. So, and here probability that you are a king. Okay. So this is probability of king and diamond divide probability of king. How many kings of diamond? 1. Out of how many? 52. How many kings? How many kings do we have? We have a king of hearts. We have a king of spades. We have a king of diamonds. We have a king of clovers. And we have a king of spades. So this will be 4 out of 52. 4 out of 52 should be, okay. So now let us do, this will be keep, change, flip. So this will be 1 over 52 times 52 over 4. This and this go away, and I'm remaining with 1/4, which is my answer. I can change it to decimal, and I can change it to percent. Okay? So that's how you do that. My picture is not clear, but you know what I mean, diamond. Okay? And then this is that conditional bar. You need to make it like that. Okay? All right. In a game, a spinner with 7 colors of the rainbow is spun. Okay? Find the probability that the color spun is blue, given that the color of one of the 3 primary colors, red, yellow. Okay. So you should know the colors of the rainbow. What are the colors of the rainbow? How do you remember colors of the rainbow? You have to remember the song. I forgot how the song goes in. I learned it in KG. Red, orange, yellow and green, blue, indigo, violet. I think that's how it goes. Find it on YouTube. Okay? So rainbow colors are red, orange, yellow, green, blue, indigo, and violet. Okay? Those are the 7 colors of the rainbow. Find the probability that the color spun is blue given one of the 3 primary colors, red, yellow, or blue. Okay? So, this is event B and this is event A. So, probability that you got a blue after you had drawn red, yellow, or blue is the probability of getting both over probability of getting red, yellow, or blue. Okay? Now, probability of getting both divide probability of getting red, yellow, or blue. Okay? Probability of getting both, there is only one blue in the 7 colors. So 1 out of 7 divide. What's the probability of getting a red, a yellow, or a blue? 3. A red, a yellow, or a blue is 3 out of 7. So keep, change, flip will become 1 out of 7 times 3 out of 7. No. 7 out of 3. And then you cross this out and you get 1/3. I'm not going to change this to a decimal because it's going to be a repeating decimal. Okay? 15 cards are numbered 1. 15 cards are numbered 1 to 50. So my total is 15. And I have the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What is the probability that the card has a multiple of 3 on it? Multiples of 3, numbers that I can divide by 3 and not get a decimal. 3, 6, 9, 12, 15. So 3, 6, 9, 12, 15. Given that the card picked is an odd number. Okay, so first, I need to pick odd numbers. Then, who are my odd numbers? So this question is asking me to first pick odd numbers. So odd numbers was the first event. The first event is 1, 3, 5, 7, 9, 11, 13, 15. So probability that I picked a card that was odd. And after I picked the card that was odd, I got a multiple of 3. A multiple of 3. So this is probability of both odd and multiple of 3. Odd and probability of both odd and multiple of 3 divided by probability of odd. So first, so this is your A and this is your B. Now, probability of both odd. So first of all, this will be out of 15. And you're dividing by probability of odd out of 15. How many numbers are odd? 1, 2, 3, 4, 5, 6, 7, 8. Did I circle? No, 9. I forgot this. Oh, no. Here. 1, 3, 5, 7, 9, 11, 13, 15. So I'm correct. Okay, now both odd and multiple of 3 are the ones I circled over here. Where are you? Both odd and here. I will circle them here. You must be odd and a multiple of 3. So you should be on this list. 1, 2, 3. So 3 out of 15. Okay. So then now you do keep, change, flip. So that will be 3 out of 15 times 15 out of 8. Those go away. And our answer is 3/8. And we box. Okay. A blue marble is selected at random from a bag of 3 red, 9 blue, not replaced. So not replaced. Okay. What is the probability that a second? So I know I have two fractions. And not replaced, I had started with 12. So this has to be 11. Okay. Now, I need to figure out what I need to put here. Is it Zaid, Nagas, Darb, Taksim? So let's see. A blue marble is selected at random from a bag of 3 red, 9 blue marbles and not replaced. What's the probability that the second marble will be blue? Okay. So this is the probability that first you picked a blue, then you did not replace to get another blue. Okay. So this will be probability of both blue A blue marble is selected at random from a bag of 3 red and 9 blue marbles and not replaced. What is the probability that a second marble will be blue? Okay. Okay, not replaced. Okay, let me think about this again. First, you picked a blue, and then you picked a second marble. How sure are we it is going to be blue? But you did not replace it. Okay, so to me, this is probability of the first blue, which will be 9 out of 12. And then it says here end. What's the probability of the second marble? And not replaced. End means to darb. So this should be 11 and this should be 8. Okay? Because you did not replace the first one. So that should be 72 over, what is this? 72 over what is 12 times 11? 132. These numbers are even, you can simplify them. 72 divide 132, you should get 6 over 11. Okay. A die is rolled if a die is rolled. If the number rolled is less than 5, what is the probability that it's the number 2? A die is rolled. 1, 2, 3, 4, 6. If the number rolled is less than 5, what's the probability that it is the number 2? So we want, first you want to roll a die. And get numbers that are less than 5. Numbers that are less than 5 are 4, 3, 2, 1. And what is the probability that that number is a 2? Probability of 2. So that's how you write your condition. Okay? First, you roll a die. You want to get numbers that are less than 5. Those are the numbers that are less than 5. And out of those numbers, you want a number that is 2. So this is probability of both 2, of both less than 5, of both less than 5, and getting a 2. Divide by probability of less than 5. Okay? Now, how many numbers are both less than 5 and 2? Only 1. So 1 out of 6. Okay? And you're dividing by numbers that are less than 5. So there's 4 of them. 4 out of 6. This should give you 1 out of 6 times 6 out of 4. This and this goes away. You get 1 out of 4. I have a feeling I did not calculate this correctly. Okay, let me write it as a conditional probability. So I see, okay. Probability of picking both blue. So probability of both being blue and probability of the first being blue. Probability of the first being blue. Blue first. But here I want blue first and blue second. But then I am not replacing. So that will be, I will have to do that here. So probability of blue first and blue second without replacing will be two fractions. Here will be 12 and here will be 11. I disagree. 9, 10, 11. 9 plus 3 is 12. 10, 11, 12. Yes. Okay. So the first one will be 9 and this one will be 8. Now we have two probability of getting a blue first. So that will be divide 9 out of 12. Okay, there you go. So if we do this, we will get 72 over 132. Okay, when I simplify this, okay, I'm not going to simplify this. I'm just going to continue over here. 9 out of 12. Then keep, change, flip. Okay, so this will be 72 over 132 times 12 over 9. Okay, so I know my times table. 9 goes here once, 9 goes here 8 times. 12 goes here once, 12 goes here 11 times. So my answer should be 8 out of 11. 8 out of 11. Okay? There. So remember, you're now replacing, and this is conditional probability. And in conditional probability, Kanun says both, probability of both, Taksim, probability of the first event. So that's how I did it. To get blue first, you only have 9 marbles, and out of the, you have 12 marbles, and out of the 12 marbles, 9 of them are blue. Now, you want to pick 2 times and without replacing, so you have to do it 2 times without replacing. Without replacing, the denominator changes. You'll have 2 fractions with 2 different denominators. Okay? The denominators reduce by 1. If they're the same color, then the numerators will also reduce by 1. If they are different colors, then you get the color. So if this was probability of picking a blue, then a red, so this would have been, instead of 8, I would have put 3 here. But because they said you need to pick a blue again, so this had to be 8. Okay? Let's move on. If 2 dice are rolled, what's the probability that the sum of the faces is 4, given that the first die rolled is odd? Okay, so what did you get first? Odd. First, you need to get odd numbers here. If 2 dice are rolled, what's the probability that the sum of the faces is 4? So you're going to get sum of faces over here. Okay? You're going to get sum of faces over here. That's the first thing you're going to do. Okay? After you do that, you have to check if the first die rolled is odd. So first die must be odd. That's the first thing you do. Then, after you do that, you want to check if the faces have a sum of 4. Okay, sum of faces is 4. Now, once you write your probability, your condition, it is easier for you to write your equation. So this is probability of getting both the first die odd, and getting a sum of 4 divided by getting first die, probability of getting first die being odd. Now, how do I know? I'm going to draw my box here, my table. Okay. All right. So here I'm going to get 1, 2, 3, 4, 5, 6. Okay, that's for my first die. Then 1, 2, 3, 4, 5, 6. You have to draw this jadwal for you to be able to answer that question. Okay, so you can see your numbers clearly. So my second die will be here. 1, 2, 3, 4, 5, 6. Okay, so we always start with our rows. We always start with our rows. So I will use the red color first. 1, 1, 1, 1, 1, 1. 2, 2, 2, 2, 2, 2. 3, 3, 3, 3, 3, 3. 4, 4, 4, 4, 4, 4. 5, 5, 5, 5, 5, 6, 6, 6, 6, 6, 6. Okay. Then I'm gonna use my black color. 1, 1, 1, 1, 1, 1. 2, 2, 2, 2, 2, 2. 3, 3, 3, 3, 3, 3. 4, 4, 4, 4, 4. 5, 5, 5, 5, 5. 6, 6, 6, 6, 6, 6. Okay. Now, this remember is die 1, and over here is die 2. Okay? The red one is die 2. Now, let me pick a different color. Let me pick green. What's the probability that you get both the first die being odd? Okay, let's first find the first die being odd. That will be here, 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 here. All this will be first die is odd. Okay. Here first die is odd also. And here first die is odd. So this is 6 times 1, 2, 3. 6 times 3, first die is odd. So 6, 18. So 18 times I will get 18 times, yes? 18 times will I get the first number being an odd number. Okay? Now, both, let's choose a different color. Let me choose light blue. What does it want? Then, no, I want sum of the faces is 4. Where will I get 4? 1, 2, 3. This is not 4. This is not 4. So sum of the faces is the 4, is 3 of them. How many are both? First die is odd, so 2. This one and this one, because both of them have green and blue. You see that? Both of them have green and blue circles. So this will be 2. So then I will get probability that you are both first die and odd and sum of 4 okay, divide by probability that you are just a first odd number on the die, on the first die, odd number on the first die. So here will be 2 and here will be 18. Out of who? 36. The total is 36. Then you do keep, change, flip, which gives you 2 out of 36 times 36 out of 18. Okay? So uh, 2 goes here once, 2 goes here 9 times. 9 goes here once, 9 goes here 4 times. 4 goes here, no, 36 and 36 go away. Why did I delete that? So this is 9, 36 and 36 go away. I got 1 out of 9. Probability that my first number is an odd number is my green circles. Okay? My green circles. And my green circles are 18 of them because there's 6 here, and there is 6 here, and there is 6 here. So that's the probability that I will get an odd number. Yes, so I'm correct. So my answer is 1 out of 9. All right, let's move on. A spinner is spun, okay? A spinner is spun and it's numbered 1 through 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Find the probability that the number spun is an 11 given that the number spun was odd. Probability that you have an 11 given you had an odd number. So probability of both 11 and odd, or odd and 11, odd and 11 over probability of odd, which is equal to probability of both odd and 11 divide probability of odd. Now, probability of both odd and 11 is 1 out of 12. is 1 out of 12. There's only 111 out of these 12 numbers. Okay, and you're dividing by how many numbers are odd? Let's count. 1, 2, 3, 4, 5, 6. 6 numbers are odd. Okay, keep, change, flip. So that will be 1 out of 12. Divide 6 out, multiply, sorry, because you're changing and you're flipping. So that will be 12 out of 6. These go away and your answer should be 1/6. Okay. How do I know this is conditional? I see the word given. If 2 dice are rolled, what's the probability that the sum of the faces is 8? Probability that the sum of faces is 8, given that the first die is even. First die is even. So this is probability. This is probability of first die being even and getting a sum of 8 divide by probability of first die being even. So you're gonna draw your jadwal. One, two, three, 4, 5, 6. Okay. 1, 2, 3, 4. Choose the different color. 1, 2, 3, 4, 5, 6. Okay. So this, I will choose my rows 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, and then 4, 4, 4, 4, 4, 4, 5, 5, 5, 5, 5, 5, 6, 6, 6, 6, 6. And then 1, 2, 3, 4, 5, 6. 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, 4, 4, 4, 4, 4, 4, 5, 5, 5, 5, 5, 6, 6, 6, 6, 6. Okay. Now, probability of getting a first die even. All this are first die are even numbers. So that is 6, 6, 6. That's 18. And getting a sum of 8. Now, out of my black circles, how many are going to give? Let me use another color. What color should I use? Let me use yellow. We need to get a sum of 8. 6, 7, 8. Okay, here 5, 6, 7, 8. Here, this is 9, this is 10. 6, 7, 8 here. So that is 3 out of 36. 3 out of 36 cells will I get the first number being an even number, and I will get the sum of the two numbers being 8. Now, what's the probability of getting the first die even? It is 18 out of 36. Keep, change, flip. 3 out of 36 times 36 out of 18. This and this goes. 3 goes here once. 3 goes here 6 times. Your answer is 1 out of 6. Okay? A school picnic offers students hamburgers, hot dogs, chips, and a drink. Okay? At the picnic, 60% of the students order hamburgers, 48% of the students order hamburger and chips. What is the conditional probability of a student who orders a hamburger also orders a chips? So he ordered a chips. So given, what's the probability of getting a chip after you have gotten a hamburger? Probability of getting chips after you've gotten hamburger is probability of both divided by probability of hamburger. Probability of both is 48%. Divide probability of getting a hamburger, which is 60%. It will be 48 over 100. Divide 60 over 100. Keep, change, flip. 48 over 100 times 100 over 60. This goes, I know that 6 goes here 8 times, 6 goes here 10 times, 2 goes here 4 times, 2 goes here 5 times. So the answer to this is 4 out of 5. Okay? A school picnic offers students hamburgers, hot dogs, chips, and a drink. Okay, we have part B. If 50% of the students ordered chips, are the events of ordering a hamburger and ordering a chips independent? So I'm going to say no. They are not independent. No, they are not independent. Now, how do I know? Probability of ordering a chips is half, 50%. Okay, let me write it like that. Is 50%, which is the same as 50 over 100, which is the same as half. Then probability of ordering a hamburger after the probability of ordering chips after a hamburger. So probability of ordering chips after a hamburger, which we did over here, and we got 4 out of 5. Now, why did I say no? My fractions are not the same. So that's why I said no. So no, they are not independent because the probabilities are not congruent, or they are not equivalent, or they are not the same. No, they are not independent because the probabilities are not the same. Are not the same. If 80% of the students who ordered hot dogs also ordered a drink, and 35% of all the students ordered a hot dog, find the probability that the student at the picnic orders a hot dog and a drink. Okay? So, probability of getting a drink and hot dog is the probability of getting a drink after getting a hot dog multiplied by the probability of just getting a hot dog. Okay? Now, how do you do this part? This is the probability of both divide by probability of hot dog. Then you're still going to multiply by the probability of hot dog. Now, according to the question, they already did for you the conditional probability. So this part came from the question, which is 80%. And you're going to multiply by the probability of hot dog, which is 35%. So 0.80 or 0.80 times 0.35. You do that in your calculator, 0.80 times 0.35. That should give you 7/25. As a fraction, change it to decimal, that should be 2800. And then you can change it to percent, it'll be 28%. Okay? We move on. All right. I will continue with this when I get home. Okay?